We at AirVani are developing a power system to deliver power to drones while they're in flight. We can see here to your left our prototype, as well as our associated graphical user interface for that. So shown here is our physical prototype of the drone. You can see this 3D printed enclosure on top of it, colored in black, which contains all the sensors and power switching equipment, which we're using to do the transition, and the pantograph arms, which are the actual power collectors. Above that is our powered rail system, which delivers voltage through the pantographs to the drone. Shown here on our GUI is a model of that. So we can see our drone here with the 2 pantograph arms, as well as the 2 rails shown above. And then on the bottom, we can see the flow of power. So right now, as the drone stands, it's connected to the battery and not connected to the rails. So we can see that flow there, as well as this indicator showing the power source is currently the battery. We can also read some telemetry from the drone's battery, including voltage and current. Once we make connection with the rail, we'll be able to read the similar values off the rail. And then shown on the bottom, most importantly, the watts of power. As the drone is in an idle state, it's quite low, but once we power it on, we'll demonstrate that. Now Sudeep will connect the drone to the rails to demonstrate the switchover. So we can see the drone is now touching the rails, and the representation illustrates that. And we can see on the bottom that the rails are now delivering power to charge the battery and to power the drone's motors. Additionally, the indicator shown there, and we can read the voltage and current now off the rails. Next, we will do the live flight demo to show the transition in flight.